Hello folks, today we're going to be taking a look at a second order linear differential equation known as an Euler equation. So how can we solve an Euler equation? So an Euler equation, first you have to know the structure of an Euler equation. It's x squared y double prime plus x y prime plus just a constant, we'll call that cy, and it's homogeneous, so it's equal to 0. Now I should note that you can also put constants in front of the x squared y double prime and x y prime, so we can actually add that right here to our differential equation. So in front of the x squared I'll put an alpha, and in front of the x I'll put a beta. So now you have the general setup for an Euler equation. So now how can we solve this Euler equation? Well, we're going to first substitute y is equal to x to the r for this. So we're going to write this out. Let's go ahead and write out our example. X squared y double prime plus 5xy prime plus 4 equals 0. So the first step in solving this is to either you can substitute in x to the r for y, or as you can see, I'm going to differentiate y now to get rx r minus 1. So let me erase the top here. So I'm going to get, if I differentiate x to the r for y, I'll get that y prime is equal to r x r to the r minus 1, right? It's just basic power rule. And then you differentiate again, and you should get y double prime. Y double prime is equal to r times r minus 1 x to the r minus 2. And then we're going to substitute that back into our differential equation. So you can see I'm writing r times r minus 1 x to the r minus 2. So now let's go ahead, substitute in back y prime and y back into our original Euler equation. So we're going to have x squared, okay, times r minus 1 times x to the r minus 2 plus, and now let's put the y prime coefficient. So that was 5x times r x to the r minus 1. And then finally we have the constant 4 times x to the r, right? Because that's without differentiating, and that's equal to 0. So now let's simplify this. That's very easy. R times r minus 1 x to the r plus 5r x to the r, right? Because there's a plus 1 up there, so it cancels out. And then finally, plus 4x to the r is equal to 0. Now I can factor out something. What can I factor out? I can factor out an x to the r. So I'm going to get r times r minus 1, and which falls out to be r squared minus r, plus 5r plus 4 equals 0. Now if I simplify this, I'll get r squared plus 4r plus 4. So that should be r squared plus 4r plus 4. And now that's just perfect squared. That's just r plus 2 whole squared, meaning that we have a double root, which is that r is equal to minus 2 and minus 2. And so now what will our final solution be? It's going to be y equals c1 x to the r 1, right? So c1 x to the minus 2, okay? And by the way, I'm going to write here ln of x because it's a repeated root. Negative 2 is a repeated root. So we're going to have x to the r, so x to the minus 2, c1 plus c2 ln of x. And that is the final solution, general solution for this differential equation. Thank you. In the next. Sponsored by Brilliant.org.